Good morning, everybody. This is our video solution to problem 6 from Superquiz 3. And in this problem, we're going to prove a very fundamental property of rings with a multiplicative identity, namely that if you take the additive inverse of the multiplicative identity and you multiply that by any other ring element, the result will be the additive inverse of that ring element. So stated more succinctly, -1 times x is equal to -x, where x is some element in your ring. Now, this is a challenging problem for students, mostly because it seems so obvious. You've known for years that if you multiply anything by -1, you get the negative of that element. What is the difficult part here is we are not dealing with integers, right? R is an arbitrary abstract ring with a multiplicative identity. And this 1 doesn't really mean the number, the integer 1. It just means the identity of the ring, right? R could be, for example, a ring of matrices, in which case this 1 would be the identity matrix. And -1 doesn't mean the negative of the integer 1. It means the additive identity, all right? In fact, let's write down, right, what these things mean. When I write -1, this is defined as the unique ring element such that when I add it to the multiplicative identity, I get 0. And similarly, -x. Okay, we say -x like it's -1 times x, okay? But that -x is just an artifact of the usual language we use when talking about the integers. This really means the additive inverse of x, meaning when I add it to x, I get 0. And it's the only solution to the equation y plus x equals 0. So if we want to prove that the additive inverse of 1 times x is equal to the additive inverse of x, then we need to show that the additive inverse of 1 times x plus x is equal to 0. So we need to show that the additive inverse of 1 times x plus x is equal to 0. Because this is how this element is defined. It is the unique element that when you add it to x, you get 0. So if we want something to equal -x, it has to have this exact same property. Now, so that's what we want to prove. So let's explore this. Well, notice there is an x in both of these. And I could take this x and write it as 1 times x. Okay, that's okay. There is a multiplicative identity, and we know that the definition of the multiplicative identity is that x is equal to 1 times x. And now I can use the distributivity, right? So I'm going to use distributivity. Of course, a lot of you might think of this as factoring out the x, okay? But in terms of the axioms, we're using the distributive law. So I'm going to factor an x out of the right, and I get -1 plus 1 times x is equal to -1 times x plus 1 times x. And here's where I get to use this property of what -1 is. -1 plus 1, right? That -1 is defined so that -1 plus 1 is equal to 0. Okay, so I'm left with 0 times x, which just equals 0, right? Well, yes, but not so fast. Okay, this is another result, right, that should be proved. In fact, in a previous video, right, from previous year, this was an exam question, and I gave a proof of this. All right, but let's just quickly summarize how that proof works. All right, so we claim that 0 times x is equal to 0, all right, for all x in our ring. All right, well, this is actually going to work very similar to what we were just doing. I'm going to take 0 times x, and I'm going to write it as 0 plus 0 times x, because we know that 0 plus 0 does equal 0. 0 is the additive identity. And now I can again use distributivity. And this is going to equal 0 times x plus 0 times x. Now, even if we don't know that 0 times x equals 0, we do know it's some element in the ring. So, and it's here the same element, right? 3 times. And so whether or not, right, it's equal to 0, we can subtract it from both sides. So I get 0 times x minus 0 times x equals 0 times x plus 0 times x minus 0 times x. Now you notice I didn't put parentheses in here, and that's because we have distributivity in the ring. Incidentally, when I'm writing minus, okay, well, what do I actually mean by that? I really mean I'm adding the additive inverse, right? So I could be writing that in each case. I'm adding the additive inverse. Okay, and that's useful because I know if I take an element and I add its additive inverse, I get 0. And over here, look, I have 0 times x plus its additive inverse. So this is 0. But now I have 0 times x plus 0, which is 0 times x. And so I've concluded that 0 times x is equal to 0. And therefore, back up here, I have 0 times x is equal to 0. From this, we conclude negative 1 times x plus x is equal to 0. And so negative 1 times x must equal the additive inverse of x.